Hello everyone, my name is Samuel Esom and welcome back to my YouTube channel. In today's video, we are going to look at something very important in Kubernetes security. We're going to look at something very important in Kubernetes security. Now, in a very simple word, we want to answer one very big question. When a pod talks to a cluster, when a pod talks to a cluster, who is that pod? Now, we are working with Kubernetes, and Kubernetes is a secure system. Now, when we looked at the architecture of Kubernetes in our second video, we understood that Kubernetes does not allow random workloads to just start calling the API server. There must be an identity, and that identity is called a service account. So by the end of this video, we are going to understand what is a service account, why we need a service account, and we are also going to see how a pod uses a service account. So we are going to see what actually happens in the background when a pod talks to the Kubernetes API. And finally, we are also going to look at a brief practical to demonstrate what we've learned so far. Before we get into the rest of the video, please, I would love you to subscribe to my channel. If you are yet to subscribe, please subscribe, give me a follow, and please, I implore you to like this video, drop a comment on this video, and if you have any question going forward, you can drop it in the comment section, and I will do well to reply to your questions. Now, so far in this series, we have seen how pods runs applications. We have seen that deployment create pods, and our services exposes these pods. Now, let us imagine a scenario where your application wants to list pods. Your application wants to talk to the Kubernetes API. Let me use this. Now, how does Kubernetes know who is making that request? Because users do what? Users use kubeconfig. Users use certificate. Users do what? Use kubectl to talk to the API. But pods do not use your kubeconfig. Pod use your service account. So you can look at a service account as the identity for your workloads. As the identity for your workloads. So users authenticate with kubeconfig, but pods authenticate with what? Service account. So what exactly is a service account? A service account is a Kubernetes object that represents an identity for pods. So a service account do what? Represents an identity for your workloads, not just pods. It is not a user, it is not a machine identity. So every pod in Kubernetes runs as some service account, even if you have never created one yourself. So I have a cluster running with Minikube. So if I do kubectl get namespace, all right, I have a namespace, default namespace. Okay, so let us try to see the service account linked to our default namespace. So if I do kubectl get service account, so I'm going to see a default service account. This means Kubernetes automatically creates a service account named default. Now let us describe this service account. So if I do kubectl describe service account, then the name of the service account default. So even if you have never created a service account, just understand that your pods are already using this default service account. So this is tied to where the default namespace, all right? And we have no labels, annotations, and the rest of it. So we are going to look into this. So now, what actually happens when a pod starts? When a pod starts, when you create a pod, Kubernetes automatically does two things. The first one is it creates a token for the service account. Then the second thing is it mounts that token inside the pod. So inside the container, there is a file, and that file is what? The authentication token. And the application can use that token to call the Kubernetes API server. Now let us look at this practically. So I have a very simple pod here. All right. Please give me a second. Okay, so I have a very simple pod here. So nano pod dot. So I'm going to, okay, sorry. Yes. So I have a very simple pod here. So I'm going to name this pod SA demo. All right, so we are going to see where this token lives and how Kubernetes mounts this token inside the container. So let us create this pod. So it's going to be created inside the default namespace. So kubectl create -f pod dot YAML. All right, so our pod is now created. So if I do kubectl get pods, I should see my pod in the container creating state. So we'll give it a few seconds for our pod to be active. All right, so our pod is currently running. So I'll do kubectl describe pod. The name of the pod is SA demo. All right, and we can see that the pod is automatically attached to the default service account. All right, so let us exec into the pod. So if I do kubectl exec, -it, the name of the pod, SA demo. All right. Sorry, please. Sorry. Kubectl. All right. So we are now inside the pod. So now, let us list the service account token path. So we are going to see that ls/var/run/secret, all right, /kubernetes.io/service account. So we have a token, which is this guy, We also have a namespace, and we also have a certificate. Let us display this guy. So I'll do cat. Let us display the token. So I'll do cat slash var slash run slash secret slash kubernetes.io slash service account dot token, or sorry, slash token. So this is a token. All right. Now this is what the pod uses to authenticate with the API server. Okay. Please understand that you did not create this token. You did not mount it. Kubernetes did it for us. So this is how pod identity works. So let us go ahead to create our own service account. So exit here. To create our own service account, again, you can go to the Kubernetes documentation and read more on service account. So this is a very simple service account. All right, so we are creating a service account called app SA. So let us apply this. I'll do kubectl apply -f. So a service account has been created. So if I do kubectl get service account, I should see two service accounts now, app SA and the default service account. Let us attach this service account to a pod. So I have a, okay, so if you check, this is us creating a pod, but the only thing we've done differently is to attach the service account we just created, which is app SA. All right, so I'm going to apply this pod. So kubectl, the name of the pod, okay, it's not going to conflict with the first one we created. So kubectl apply -f pod with service account. So let us describe the pod. Kubectl describe, or let us check if our pod is running. Get pods. So we have two pods. This is the second one with our own custom service accounts. All right. So if I do kubectl describe pod SA demo 2, so we should see that the pod is attached to what? The app SA service account. Now let us exec into this pod so that we also confirm that we did not create the token. All right. Kubernetes did it for us. Get pods. So kube ctl exec -it SA demo 2. All right. /bin/sh. All right. So I'll do ls/var again /secret/kubernetes.io/service account. Sorry, this is not a complete path. So ls/var/run then before secret slash Kubernetes.io slash service account. So we can also see the same thing we saw with the default or with the first pod we created. So every service account gets its own token. The pod uses the token of the service account it runs as. Now let us try to access the Kubernetes API. Let us try to access the Kubernetes API. All right. So what I'm going to do is to try to list pod, all right, with what? With our service account. So I'll simply do kubectl. Before then, let us get the name of our service account. Kubectl get service account. All right. So this is the default one we created. So let us try to use this service account to authenticate to the Kubernetes, or authenticate to the Kubernetes API. All right. So I'll do kubectl auth. Can I list pods? So I'm simply asking the Kubernetes API if I can use this service account to list pods. All right. Can I list pods as then the name of our service account? Um, our service account. Then the name of our service account is created in a default namespace. All right. Then the name of our service account, which is app SA. So I simply get no. All right. So it's going to return yes or no because currently what I have is just a service account, but I don't have the permission to talk to the API. All right. So this is why creating a service account is not enough. So we've created a service account, we've attached it to a pod, and we have verified that the token exists. We have used the token to call the API, but yet the request still fails because a service account only gives an identity. It does not give permission. A service account only gives identity. It does not give permission. This is why we are going to consider the, the next aspect, which is RBAC. RBAC. So let me take this out. So an RBAC is very important for authentication and also for authorization. Now, authentication is who you are. Authorization is what you are allowed to do. So RBAC is only authorization. All right, RBAC does not log you in. RBAC only decides what you can do after you are already known. So let us look at the full meaning of RBAC. So RBAC simply means Role-based access control. Role-based access control. All right. So it is a Kubernetes permission system. It controls access to resources like ports, secrets, etc. So we've seen what a service account can do, which can only give identity. And we've seen how pod gets an identity. And we also try to authenticate with the identity to, or yes, to the API server. And we saw why the request failed. All right. So in RBAC, you are going to do what? You are going to define a permission. And this permission can be what? Namespace wide, or you can say this permission can be tied to a particular namespace, or it can be tied to the whole of the cluster. All right. So in essence, it is referred to as role and cluster role. Then we'll have an identity that is going to use this role. So an identity can be what? It can be a user, it can be a group, or it can be a service account. So in a later video, we are going to see how users can actually use RBAC to authenticate to a cluster. But for today's video, we are going to only look at service accounts. Now, we've seen permission, which can be role and cluster role. We've seen an identity, which can be user, which can be a group of users, which can also be service account. So the next thing we are going to look at is another concept, which is binding. All right. So we have a role binding. We also have what? A cluster role binding. So now, imagine a production cluster. You have multiple teams. You have monitoring tools. You have developers. You have support engineers. You do not want your monitoring pod deleting deployments. You do not want your developer deleting secrets. You do not want your continuous integration job deleting namespaces. So our back is going to do what? Create security boundaries. Now, let us look at, we've seen service account as an identity, all right? Now, a role. A role is simply a list of allowed operation inside one cluster. All right. So a role is a list of an allowed operation inside one cluster. Sorry, inside one namespace, not cluster. A role is cluster namespace wide. So it does not say who can use it. It's only describe permission. So this is how role a role resource is written. So if I nano, so this is a role. This guy belongs to this API group. The kind of object we are creating is a role, and this is a name this role is going to assume. And I told you that a role is what? Namespace wide. Now, these are the rules. Now, for API groups, this particular API groups belongs to what? Resources like ports. All right. It belongs to resources like ports. So that means this rule is going to apply to ports. Now, the verbs are simply the action this role can do. Like it can get ports. It can also list ports. All right. So it can only list and get ports. If you want it to be able to delete ports, then you can list your verbs in this section. So you can take a look at the Kubernetes documentation to read more about this guy. So before I apply this, I am going to create a dev namespace. So kubectl create namespace dev. Then kubectl apply -f role.yaml. So our role has been created. At this point, nobody can use this role just yet. At this point, nobody can use this role. Okay. The next thing we are going to do is to bind this role to either a user or a service account. All right. To bind this role to either a user or a service account or a group. But for our demonstration, we are going to bind this role to a service account. So role binding. Now, we have this guy as the API group this guy belongs to. Now we are binding this. Okay, this is a name this guy is going to assume. And of course, in the default, the development namespace, the one we just created. Now, the subject, all right, the subject is where you explain or where you, explain your binding. Now, the kind here, we are binding this guy to what? A service account. And we created a service account called what? AppSA. All right. Now, the role ref. The role ref, subject.role ref now refers to our role. All right. Because we are binding this guy to that role we created, which was port reader. Okay. But then we don't have a AppSA in the default namespace. Okay, let us try to create a service account in the default namespace. So I'm going to exit this. All right. So I'll do kubectl get service account -n dev. So we, all right, okay. This works. So a service account is can be used with any namespace. All right. So I'm going to apply our role binding. All right. So kubectl apply -f role binding. So this is going to create our role binding. All right. So if I do kubectl get role -n dev. So we created a role binding. So it is bound to this role. All right. So now the verb in our role was what? List and also get port. So let us try to talk to the API server to decide if we can list port. So what I'm going to do is kubectl can I list port, because list is also part of the verb. All right. Can I list ports as a service account? All right. And the service account is okay. Can I list port in the dev namespace? Then the service account name. What's the service account name? Please hold on. Before we do this, the namespace, sorry, please. The development namespace has just one default service account. All right, so let us create a service account called so kubectl create service account, then the service account name. So I'm going to call it let us try to see which namespace the role was bounded to. Okay, this is the name of the service account, app sa. All right, so kubectl create service account, then the name in -n dev. All right, so if I do kubectl get service account -n dev, okay, I should also see the app service account here. All right, so if I do kubectl get role binding, okay, -n dev, okay, so our role is now bounded to this this guy and in the dev namespace. So let us try with a command to confirm. Kubectl can auth, can I list ports as a service account in the development namespace? All right, and the service account name is what? App sa. Okay, sorry, auth, this is incorrect. All right, so let us try to apply all of this guy in order. I think we missed the namespace first. So I'll do kubectl get role -n dev. All right, so kubectl delete role -n or delete role, the name of the role, port reader -n dev. All right, so kubectl get role binding -n dev. All right, so kubectl delete read ports or role binding, the name of the role binding, ports, all right, -n dev. All right, so if I do kubectl get role, there's nothing there. Get role bind, there's nothing there. All right, so let us take it one after the other. Okay, so we have a namespace running, which is dev. All right, so nano role.yaml. Okay, so kubectl apply -f role.yaml. So our role is created. Okay, so kubectl apply -f role binding. All right, so all right, so if we do, let us try to rerun the command again, and I hope this time it will work. Oh, we still get no. Um, I think we are missing something in the command. So, all right, okay, let us try to specify the namespace we are working with. Let me copy this exact thing. All right, so I've added -n dev. Okay, okay. So this means that we can list pod. So we had two verbs, list and get. Yes. All right. So if we try to check if we can delete pod in the dev namespace, delete. So we have no. All right. So if we try to check if we can create, we have no. So the only verb or the only action we are allowed to do in this namespace is to list pod and also to do what? To get pods. Now remember that the role is actually namespace scoped and the role binding is also namespace scoped. So we also have cluster role and we also have cluster role binding. So a cluster role is exactly like a role, all right? A cluster role is exactly like a role. So if I do, this is what a cluster role looks like. So in the kind, we add cluster to the role. So cluster role, it's exactly like a role, but the only difference is that it is not tied to a namespace. So you usually use cluster role for permissions that should exist across many namespaces, like cluster-wide resources. Just like cluster role, we also have cluster role binding. All right. We also have cluster role binding. So we have cluster role binding. Okay. So the cluster role binding also do what? It also a cluster role binding lives at the cluster level. So it's still the same thing, just that in the object section, you refer to it as a cluster role binding. So that means your service account can use this cluster role everywhere. So far, we have seen how pods authenticate to the API server. All right. Now, in the coming video, we are going to also see how users, because this is only for objects, we're also going to see how users can also use RBAC um, to authenticate or use permissions. All right. So it is going to come in a very later video. All right, guys, this completes our Kubernetes access control story. All right. So from now on, whenever you see a pod calling the API or a user running kubectl, you should immediately think that you should immediately think, who is this identity? You should also think in identity. You should also think in roles and the scope. So if you benefited from this video, please, I would love you to subscribe to my channel. You can also share this video with your friends, and do well to like and drop a comment in this video. If you have any question, you can drop it in the comments and I will attend to each and every one of them. So thank you so much for staying up to this time, and I'll see you in the next video.